Hi. You'll have to bear with us for this talk because we have one mic, or two mics between three people, so it might get a bit janky. But welcome to our talk. So we are doing a data engineer, scientist, and an analyst walk into a bar. And what we're hoping for you to get from this session is understand our jobs, understand what each of these roles involve, how we interact, how they're different, and how really as well how it's different for every person as well. So two data scientists, for example, won't be the same. So we'll start with intros. John.
Thank you. So I'm John. I'm a senior data engineering consultant with Advancing Analytics, doing data and engineering stuff for nearly 20 years, all in, across all different cloud platforms, things like that. My pronouns are he and him. And yeah, we'll go through and explain what I do as a data engineer, which is a glimpse into the world, but you'll probably be doing something similar, maybe a different, that type of thing. Outside of work, I enjoy riding my motorbikes. So that's all good fun. I am standing in for Grace, who unfortunately can't be here. She's a little bit ill, unfortunately. But you just contrast what my career bit, but you look at what Grace has done in the short time that she's been here. Again, very different type of profile, really competent, one of the best engineers I've worked with. So yeah, fingers crossed, should be able to present this another time with us. With that, over to Bethany.
Hi everyone, I'm one of the analytics consultants at AA, and my experience is rather weird. My industry, how I got into it, was very different to most people's, didn't have a formal qualification or anything, and accidentally got picked up on when I was doing data entry. So my experience looks completely different to most analysts, and that is a very common trend with analytics. It's one of those ones that everyone is completely different, everyone has different specialisms. Me specifically, I absolutely love visualization and love all of that, the charts and everything. But everyone is different, and outside of that, I'm heavy on fitness really, which is a weird one. But yeah, so yeah, on to Tori. Do you want to grab?
Yeah, hi. So I'm Tori. I'm a AI consultant, which is recent. I am still a data scientist, I like to say. Pronouns are she, her, but I've also been in the industry for 5 years. I'm a Microsoft AI MVP. I just like to talk sometimes. I do some work with girls and data, volunteering at schools, and I host a podcast, which we haven't done an episode for a year, so I should probably stop putting that on my slides. And yeah, so data scientist, but I sometimes describe myself as an AI consultant or a machine learning engineer, and hopefully go in a bit more detail about sort of why. Yeah, I will pass to John to get started with talking about engineering.
Oh, that's all right. Sorry. So, goal as a data engineer is essentially I need to get something from somewhere into some coherent form, ready for my colleagues to actually do some meaningful work with. They're the ones that will help the business interpret the data and so on and so forth. So it's really sort of the front end side of things. It's a lot of platform engineering as well, bits and pieces like that. And when we start looking at the skill sets for a data engineer, so I mean, can I show of hands, who here consider themselves a data engineer already? A few of you, that's good. Aspiring data engineers? Yeah. Yeah. So yeah. Yeah. So it's sounds like job titles aren't catching up with the work that we're doing. So yeah. IT can. Ah. Cool. That's all right. Yeah. So yeah. So as you're saying there, I think is the data engineers deal with the data modeling a lot of the time. You'll be engaging with the end users, with the business, understanding what do they want to derive from that insight, and you kind of sort of sit across the sort of areas where that spans multiple roles. Now, when you start thinking about the skills profile, a lot of people think it's something like this. A data engineer is really wide, lots of breadth, and you've got to know a lot of stuff in great depth. So you're looking at things like platform engineering, so infrastructure as code. How do we set up the networking? How do we set up the connectivity? Do I put a self-hosted integration runtime for ADF or whatever in place so that I can get ETL to move the data from one to the other? I mean, architecture as well. I mean, how am I going to architect this? What am I going to set up as a reference architecture? The patterns and practices I'll use for the infrastructure components, the patterns and practices for the pipelines, which modeling techniques, all of that sort of thing. Cloud engineering. A lot of the big analytics suites now sit up in the cloud. You've got Fabric, you've got Databricks, Snowflake, all of those predominantly cloud-born. Gone are the days of the sort of on-premises Hadoop, just because it's a lot easier to scale up, scale down, cost-effective. Information security, this is a key one for anything really when we're dealing with data. It's got to be secure. You see more and more customers now who want secure networking, things like that. Coding, well, I've got to write SQL, bit of Python, maybe some C#, possibly some JavaScript. It's going to vary. Communications as well, understanding how to speak to people, convey concepts to technical and non-technical people within a business. The reality is, it looks kind of more like this. I've got different depths of knowledge in different areas, and different breadth within those depth areas as well. I mean, I come from a predominantly platform engineering background, heavily infrastructure focused, optimization. I was a DBA, and we'll look at some of the career path that took me to where I am now. But you don't need to understand everything. I mean, you go online and you'll see top 10 must-have skills, and you'll see it's almost becoming a meme. You've got to know this, you've got to know this, Python, SQL. The reality is, nope, it's a load of crap. Put bluntly, John's top 10 things are whatever skills you need to get the job done. You know, it's going to vary. Different organizations are going to have different tech stacks. The way that we work is going to evolve. I mean, you've got Data Vault, you've got Kimball, you've got Lakehouse, which builds on Kimball sort of principles for the way you do modeling. There's a whole raft of different things that you're going to look at, and it's going to evolve over time. Your skill set's going to be constantly evolving. The one thing you do need to look at, I mean, when you start thinking about the different elements that fall into it, is I just need an inquisitiveness and an ability to learn and a good way to communicate. Those are the key skills that we need. The technology we can learn as we go along. We'll pick something up, we'll put it down and move on to the next thing, you know? So give you some illustration of how that worked for myself. Back in the mists of time, I left school with no A-levels, barely any GCSEs, went off to do some retail, worked in customer service, worked in a call center, drove forklifts, set up B&Q stores, that type of thing, end up delivering IT equipment in a van, and they moved the build function for PCs from the desktop team into the warehouse. I had an affinity for it, got pulled over by the desktop team, headhunted around a bit more, moved to the application and database support team, then a bit of BI development, good reporting services, you know, got to cut your teeth somewhere. I even wrote Oracle Forms for a bit, did some time as a DBA, back to BI developer, off to Microsoft to work as a PFE, very interesting. That's where I got some of the consulting experience. Went off and did technical pre-sales work for a software company. I don't know if anyone here's heard of SQL Sentry back in the day. I went there for a while. Product manager for a while as well. Again, looking at that technical aspect, requirements gathering, interpreting things from customers. Back out database engineering, built a database organization, insourced from an outsourcing provider where it had been there for 15 years. Off to AWS, do a bit of solution architecture, working with Redshift and all the Halo services that sit around that, infrastructure, storage, you name it. And then a bit of time as a developer, building a new sort of cloud analytics platform, software as a service. And then here I am now, data engineering at AA. So overall, I mean, that's my path. But I mean, everyone else, you're going to have your own path to get where you are now. And it's one of those things. My ethos there is it's always worth talking to people, always worth listening to what opportunities are out there. Never rule anything out because something interesting could come along and it's like, oh, okay, we'll go and do that. I mean, the day in a life, I have a bit of a stand-up. I do some project admin, maybe a bit of research, depending on what project I'm on, maybe client stand-up. Then off we go, project work, so that could be coding, could be collaborating, pair programming with peers, could be doing some documentation, which is important. It's not very nice. Lunch, very important. Okay, make sure you take a break. I learned the hard way, don't work 15-hour days all the time because it burns you out. It's not fun. So make sure you take your breaks. Back to coding, doing more project work. And there's going to be some meetings in there as well. I've just stuck it in as 1 hour block there. It could be sort of 15 minutes here, an hour there, depending on what the course of the day is. So it could be I got to go and have a modeling meeting with a client, or I could be dipping in doing an interview for colleagues, that type of thing. So it's a bit more varied, but by and large, a lot of that time is spent building something, pulling data in, ingesting data, getting it into a format so that my colleagues can then take that information and pass it on and use it for the business. So that's a very sort of whistle-stop tour of my world of data engineering. We'll take questions as we go through, but if we go over to the analyst side of things, and do you want to explain what you do? There we go.
Thank you. So, what is the main goal of a data analyst? As a whole, we want to collect, interpret data to help a company take actionable steps to improve its performance and meet all of your goals. Now, that's obviously an extremely formal way to say that we want to do something good with it. We want to make it usable for whoever's using it and whoever's looking at it to be able to look at what they're looking at and take actionable steps, basically. But as I said before, every single analyst is different. You may have an analyst that doesn't look at the data until it's cleaned. They may only build dashboards. They may only speak to clients. They may only do data modeling. It's such a broad subject that everyone is completely different. Now, my career, as I said before, started out very odd. Exactly the same as John, pretty much the same, hardly any GCSEs, 2 barely A-levels, and had no idea what I wanted to do. I have a background, you're going to make me say it, aren't you? I had a background in swimming. So previously...
Olympic swimmer, everyone.
Okay. I got into the Olympics when I was 16 and didn't go because of my GCSEs. Hence the fact why I don't have many GCSEs, because that was not the plan. Ended up leaving that, becoming a lifeguard for a bit, which was a bit of a step down, to be honest. But did retail work for a bit, as every single 16, 17-year-old does, and got into admin, which is a mistake. But I then decided it was probably time I went to university because I had no idea what I wanted to do. Now, there's not many courses you can get into when you don't have many qualifications in the first place, and I got into some absolutely tiny course in some form of psychology up north. Decided to take a gap year, continue to work, took a basic data entry job, and ended up getting picked up at that job by my manager at the time, who saw something in me. It was very, had no idea what I was doing. I got very lucky. Someone had left for 3 months to go on holiday to Europe, and we were all very jealous. And there was an opening, and I stepped up to it, ended up pulling myself out of the previous job role by accident because I streamlined myself out of it too hard, and got trained up on Tableau, which I then went to work in for 5 years at that company, and absolutely loved it. Eye for detail, all of that kind of stuff, but went into, in exactly the same company, I became a compensations investigations analyst, which was a very nice way to say that I helped with finance, and I produced all of their dashboards, everything that we wanted to know that we'd never tracked before. The company I worked at had never previously tracked any of their data. They just looked at it and had no idea what to do with it. So I was that person who came along, and everything I did was magical to them, which was a brilliant confidence boost. But at the time, at the point, I needed to move on, and ended up joining AA, and that's where we are now, and I am very much in the midst of consultancy. So the basic data analyst skill profile is very much a mixture of technical and soft skills. You can have either or to start, and you're going to learn to develop either of them. Now, as my experience went, I had the basic soft skills, but nothing else, and managed to upskill myself to that point, and I was absolutely fine. But some people come into analytics through an engineering way. They come in through a data science way. They see they have that interest in mind, and so they've already got programming languages. They already know how to do basic data modeling. But in my case, that wasn't me. But that is also a very common route. Also, some people don't know they're an analyst. They might be a data modeler, they might be something else, but data analytics, basically, as John presented before, there are main pillars to it, right? There are main things, and ideally you want everything to look like this. You want everything to be broad, but you don't want to be too defined in something specific. That's what you're always told. Now, for me, that's not the case. Mine is slightly ridiculous. So I see my analytical mind, right? It's the way I think, the way that I'm able to present something and show a story through data that you can do it, you can be taught it, but it's something that for me it was innate, so it will always be my strong suit. Now, programming languages, I'm not the best, to be fair. I can do basic SQL, I can do the tiniest bit of DAX, and everything else I will very much lean on engineering to do so. Same with data modeling and data cleaning. I've only just started getting into those things. I thought I was doing data modeling when I was putting stuff in the dashboard, because I had no idea. But as long as you've got a basic, broad idea of what you want, you can be an analyst. So my basic day would look, so we'd have morning stand-ups because we're consultancy. I would have a company stand-up, catch up with everyone who is in our consultancy, and then whatever project I was on at that time, exactly the same thing. Now, my big chunks of my day, they're so broad, it's very difficult to put into a specific set of something. But it could look like this. I could be building data models, I could be assisting with engineering, I could be creating visuals, I could literally just be researching how to build a specific graph that a client has asked for. And the most boring one is the documentation, and we tend to have things called lunch and learns, which most companies do, but ours aren't always on something technical. We could have it on something absolutely insane that is a specific interest to someone that no one has ever heard about. But sometimes, yeah, we're definitely always going to gain new knowledge, but it may not be specifically work related. Now, if you are an analyst, you're going to have a collaborative work environment. You have to, right? I work very closely alongside engineering and data science because analysts look at the entire picture. And that could be us co-working together, just assisting each other on basic things, and it could also be on very more intense stuff that there is no way an analyst would be able to do on their own. Now, playbacks, much in the same vein of communicating with clients, it would be partially my job to pull back everything that we have done over the past few weeks and communicate it back to them and see what results we've delivered. And more project work. So exactly the same thing that we were talking about earlier. But yeah, if I move on to Tori.
Thank you. Who here is a data scientist? Tough crowd. Anyone want to be a data scientist? Nice. Good choice. Cool. So my background, I'll whiz through it. I did go to university, but still not in anything data related. So about 10 years ago, I don't know, I just really wanted to be a hacker. So I took forensic computing and cybersecurity. The only thing I knew is that I liked to code, and hacking sounds cool, right? Yeah. So I studied that for 2 years, and we did like a placement year, so a year where you spend a year internship in industry before you return for your final year of university. And I did mine from a consultancy called Ernst & Young. And I worked in a department called e-discovery that was quite a small one. And every time I mention it, no one's heard of the word e-discovery before. But in short, it's around sort of using forensics practices to extract data from computers or phones, and then analyzing that data, presenting that data to lawyers for them to go and use into court. So it's kind of like the bridge between data analytics and forensics. And that was kind of where I fell in love with data. So you'll see I returned back to my forensics computing and cybersecurity, but this time I had to beg my lead lecturers to let me into some of the data courses that I'd been locked out of because I'd gone for such a niche course. And because of that, I was able to graduate university and get my first data job. So I joined a small consultancy, and originally I joined as an analytics consultant, but I very quickly niched into the engineering side. But I really picked up like a personal passion for data science. This is around where neural nets were getting loads of interest. I don't know if you remember like data scientists being the sexiest job of the 21st century, and I was like, yeah, I want to be sexy. So I went and I really threw myself into data science. And I moved into my next role, specifically wanting to do data science, right? And I've been with AA for 4.5 years now, and when I first joined, we were a bit smaller. I couldn't be so selective with the projects that I did, so I did start out more as a data engineer, but now I like to say I'm fully data science, fully ML ops, and we have recently branded ourselves to AI consultants as well with the recent boom of generative AI. Data science doesn't quite fit under that so nicely, so now here I am as an AI consultant. But a data scientist. So, a goal of a data scientist, and there's a big paragraph here, but really it's extracting data using different techniques to inform decision making, improve processes, develop products, or solve complex problems. And you might think this sounds very similar to what Bethany does. And I always think that the main difference between what me and Bethany do is just the way we do it, basically. And the reasons why we do it. So a lot of data science is involved. You do lots of machine learning, lots of statistical analysis, lots of Gen AI now. So that's the main difference. The other main difference is our general skills profile. So I've got some main pillars here. I've tried to be a little bit specific about the stuff that I have. So machine learning is a huge, huge part of data science, part of the technical part. Some of that might involve sort of shallow machine learning, so your supervised, unsupervised learning. It might involve the deep machine learning, like neural nets. It can involve some elements of analytics and engineering in data featureization. We need to be able to build our own features and pipelines. I mentioned before, generative AI has been a big boom of that over the last sort of year and a half. So now that's a huge part of a data science role, I like to think. And other things as well, such as like time series forecasting. There's a huge breadth of stuff that data science is involved with. I said before as well that I think of myself more as an ML ops engineer too. So there's a huge amount of ML ops skills that are involved with maybe a data scientist too. Has anyone heard of ML ops? So machine learning operations, it's kind of like the DevOps for data science. So you need to know a lot about DevOps. You also might need to know a lot about CI/CD, about orchestration, about the general sort of platform or cloud platform that you're working with. And you might need to know some even more techie stuff like containerization, maybe Kubernetes, Azure Functions, etc. When it comes to tools as well, there are certain loads of platforms that I can work on. So Databricks, Azure Machine Learning tends to be my bag. You might do more of a sort of low-code data science tool. Doesn't make you any less of a data scientist. So that might be DataRobot, Dataiku. When it comes to languages, I'm very strong personally in Python, and I think most data scientists now might be. R, I would say about 5 years ago, was a really prominent language in data science. Now, very less so, and I can hold my hands up and say I've not written one word of R in my life. PySpark and Scala, if you're working with distributed systems, you might want to work with PySpark Scala. Rust, I know we've got some Rust fans in the audience, but Rust is really picking up as well. Also have not written a word of Rust, and SQL as well. And then the final things that cross a lot with what John and Bethany do in engineering and analytics. So you need to have really strong communication skills in data science. Wasn't really a natural at this. This is something that's really come with time. But a huge part of the job is around explaining data and explaining reasonings to stakeholders and to your team. So that's a huge part of your soft skills, as well as the curious mindset, sort of the adaptability, and your ability to hold a presentation as well. So how this would look for me. So I mentioned before I started as an engineer. My data science knowledge has come from really just personal development. So I have a fairly broad machine learning skill set, but not hugely deep. So again, I work far more on the MLOps side, which is around taking work that data scientists have done and putting that into a scalable DevOps enriched environment. So you can see I've got the breadth and the depth in MLOps. As well with tools, my whole career I've worked on Azure, so I consider myself quite narrow but fairly deep on the tools. As well as coding, I work mostly in Python and generally not anything else these days, and soft skills too. So, with data scientist, I wouldn't say is a particularly new role, but there are lots of new roles sort of popping around in the realm of data scientist. I don't know if you've heard of any of these, but you might be reported as a machine learning scientist, which is when you're far more involved in the machine learning side than you are in the MLOps or the deep learning side, for example. You might be an NLP specialist, so like a natural language processing specialist, a computer vision specialist. You could be a machine learning engineer, so the stuff around the MLOps side. You could be a generative AI specialist, or you could be my favorite title, which is an LLMOps engineer, which is generative AI, DevOps, and machine learning ops all smushed into one as well. So a bit of a whiz through of my day. I would say quite similar to the rest of my team. We have our normal stand-ups. We're a consultancy. We do lots of project work. So we'll have a company stand-up, and then we'll have a project stand-up. So that'll be with all the stakeholders of the projects that I'm currently working on. My day doesn't normally look like this, but on a productive day, maybe I would spend 3 hours in the morning coding. So that might be developing models. It might be productionizing those models. It could be doing some feature engineering to prepare for my models. I would have my lunch. And then my favorite parts of my day are always the cross-team catch-ups. Within the data science team, we don't always work on projects together. And a huge part of our job is upskilling and learning what other people are doing in the industry. So the reason it's my favorite part of the day is all of the data scientists in our team all get together. They talk about what we've been working on, the tools that we've been using, things that we're getting stuck on, and I learn a huge amount here. I've then got stakeholder playback, and like I said before, communication is a real huge part of the role. So maybe I would spend an hour talking through sort of model results, evaluation metrics, maybe go through some dashboards as well as part of the playback. And then again, this is a very productive day, so I spend the last bits of my day setting up and doing some more coding as well. So, I don't know if you've noticed, there's been a huge part of this talk where we've all mentioned very similar skills with different flavors. So there's a huge amount of overlap with the work that we do. Yeah, so programming, communication. Communication's, I think, important for all three of us. Problem solving as well. You can't really work in data without loving solving problems, I think. And that decision making and analytical mindset as well. And then there are some slight more overlaps when it comes to just between two people. So me and John, for example, we spend more time with Python, and we spend more time with Databricks than Bethany, for example, and spend far more time in CI/CD than I enjoy. I don't know about you. Yeah. And then, yeah, Bethany, John, did you want to talk a bit about how your jobs are similar?
Mm-hmm. So in regards to sort of data modeling and stuff, the only way that I can produce a correct data model is really by going to engineering. Because specifically, if I'm wanting to present a data a specific way, there's a certain way that I want it to look. And in order to get it that way, I don't always have the skills to do that, then I will go to engineering. As with SQL, we both use SQL all the time. and data cleansing and curation are very similar.
So yeah, so I mean, the overlap for the engineering piece, I mean, as Tori says about the CI/CD, that's something that I really enjoy. Automation. I want to do a task once, and then right, moving on, next one. Let's automate that because I'm really lazy. Um, it's one of those things that if we can put it into there, and make it repeatable, the less chance of me doing something manually means there's a reduced chance of something going wrong. People in the loop make mistakes. I've been there. That's how I learned many lessons over the course of my career, from wiping out production systems by accidentally putting a typo into some of my infrastructure as code. So with CI/CD, it's great. You can have no mistakes or one or mighty massive one. But normally you can fix it and get back pretty quick. So yeah, but I mean, on the analyst side of things, the modeling piece is driven a lot with the analyst, and there'll be a lot of collaboration there. It's rare to have one team or one sort of small group who'll see a project from start to finish. There'll be people rolling on and rolling off, and that collaboration and that handover is key, which is why things like documentation and that communication skill is important. That feedback, the stand-ups, the replays. We use sort of Scrum, Agile methodologies when we're doing projects, so it's very easy for people to sort of pick up and put down as they're bringing things in and using the skill sets that they have. When I'm working on one at the moment, the team, they'd been on there for 3 weeks. I come in, the two of the others will roll off, and we're already sort of in there. We're landing data, we're cleaning it, getting it ready to move it through up into curated layers for other members of the team to then take over and start working with the client and work on from there. So there's a lot that we can do there, and that overlap, it really sort of materializes not only as something like this with skills overlap, but it's also that collaboration and making sure we're handing off between each other very effectively as well. So, sorry, do you want to, well, before we go any further, I mean, has anyone got any questions? Or, I mean, is this resonating with you? Is this something that you see day to day? Is there anything that we haven't covered, for example? I mean, we're building data warehouses, now we're building lakes and lake houses and things like that. From an analytics perspective, the engineering piece, the analyst and the scientist, it's all still moving forward. I mean, is there anything that you think that you do that we don't, for example? So, I mean, obviously everybody does slightly different things. Well, I guess we're on the money. In that case, I'll hand back over to Tori to work through some of the scenario.
Yeah. Awesome. So just to wrap it up, I think to highlight as well how our roles are kind of similar, but also kind of different. So this is us three. I tried to colour our shirts to make us look like what we're wearing, so I hope you appreciate that. But we arrive at a bar, and the keg is broken, and there's no beer for anyone to drink, and we all look sad. I've had to Photoshop everyone's happy faces upside down as well. So I guess, John, how would you approach this problem?
So from an engineering perspective, it's okay, well, where is the keg? Where is that source? What do I need to get? Where do I need to take it? Where do I need to put it? Okay, so we start going in. All right, I found it. What's the current state of it? Oh, it's looking all right. It's a little bit sketchy in places. It's got a few dings in it because, well, let's face it, they get thrown around a lot, much like our data. So we'll pull it out, and then it's really a case of, okay, well, is it fit for purpose? Is it gone flat? Is it something that's actually it's sort of gone bad or something like that? The pipes, the lines, are they clean? You know, if I'm right, plug it all in, okay, we're going to push it through the pipes, through the pipelines, and it comes out the tap, and it's like, actually, this is rank. We need to go back and we need to do some cleaning. You know, sort of starting from that source point all the way through until, boom, I got myself a nice sort of clean pint, not too fizzy, not too much head on it, nice. So that's the sort of approach that, from an engineering perspective, go back to source, find it, and bring it all together and bring it forwards. I mean, some of it could be a case of the source is totally, it's mangled, it's beyond redemption, so got to go and find a new source, go and find a new keg, that type of thing as well. So it really is sort of going back to source and just working it all the way through, and it's a case of, well, how many of us want beer? Which beer is it we want? That what we got. But go back to source, work it through. What's the state? Clean it, make it rational, make it good, and then we're in a position to have a nice pint. So,
going off John, you would want to fix it, right? That's your aim. Mine is to look at why it happened and to avoid it happening again, right? So why did it break? Was there something wrong with it in the first place? All of the things that you listed to say, like to aim to fix, he's looking at it from a perspective of aiming to fix it. I'm looking at it from a why. And so that it doesn't happen again. I'm apparently not interested in the bit. I just want to know why it's breaking and why this is my issue at this moment and why I can't have any.
Yeah, thanks, Bethany. Yeah, so John fix it, Bethany find out why, and then it's my role to make sure this never happens again, right? What can we do to predict when kegs are going to break? So maybe we put some sensors on the kegs. Maybe we collect a load of data about the kegs and we keep that and we run it through some machine learning algorithms. Or we do some generative AI. But our goal really is to see into the future, to use our predictive analytics and our statistical modeling to make sure that this is never going to happen again. So we can all have a nice beer. Yeah, so I hope that's kind of cleared up kind of the confusion maybe between all the data roles. And there's a huge amount of data roles that we haven't covered. I think we've just picked the main ones that we see and that we are, really. But yeah, I guess we've got 15 minutes for questions? 10 minutes for questions? Yeah, has anyone got questions to fire at anyone in particular? Yep. So the question is sort of how, as an analyst, would you scale up and learn data science in order to become a data scientist? I think my main tip is to just do stuff. So I guess my main tip is build up a portfolio of different projects that you work on. I don't know if you've come across Kaggle before. Kaggle is an amazing resource. If you just go to, I think it's kaggle.com, they have tons of data. It's really like a little data science sort of repo for everyone to use, where there's data sets and then specific problems associated with it. So that might be sort of, here's a load of data we have on people's cancer screenings, and we also have related to that whether or not they had cancer after the screening happened. Can you build a model to predict, based on the data going in, whether people have cancer, for example? So you have the problem, you have the data, and there's tons of people posting how they've solved the problem and the models that they've built and the techniques that they've used. So go try, build something yourself, maybe follow along with what someone's doing, or follow another tutorial and apply it to that data, and kind of do that to a load of different problems. And you've built yourself a portfolio in which you've learnt the skills, but also you've got sort of, you can show other people that you've learnt them too. I think that's probably my biggest tip. Awesome. Any questions?
So the question is, sort of to summarize, do I think that data engineers should understand and have an appreciation and depth of knowledge for every cloud platform? No. Concentrate on one to start with. You'll hear a lot of people, we're going to go multi-cloud because of the resiliency and so on and so forth. And that's quite frankly junk. You should be building a solution on a single cloud, and then you might build a different solution on a different cloud. But focus on one, because the skills that you learn are transferable. Fundamentally, they're all the same. They just call things different names. And there's a few minor tweaks that you'll see when it comes to some of the configuration options and so on and so forth. But I mean, for a start, if you start off on AWS, coming to Azure, if you understand how to work with AWS, Microsoft's documentation has a big sort of section where you can say, well, this is the service in AWS and this is what it maps to in Azure. So you can learn. I mean, that's how I went the other way. I spent nearly a decade working with Azure, and then I pitch up at AWS with about this much experience and then transfer my skills, because it's fundamentally the same approach to doing things. You just need to know what the services are called and which buttons you need to push. But fundamentally, it's the same thing, because you can only do networking so many ways. There's only so many ways you can spin up a virtual machine or spin up a Kubernetes cluster. It's all there, really. So no, you don't need to know. You just need to have an appreciation that your skills will be transferable and a willingness to do that should the need arise. And then that will just build over time, and then you will have an appreciation and knowledge of both clouds, at which point you become more attractive to the job market because you've got that, and that's where things like the consulting comes in. So yeah, is that cool? Any more questions? Some of the question is about what do we think of Ultrix as a tool for automatically doing the stuff. There are a number of tools on the market. Again, I've never used that particular one. I tend to fall back to doing the work by hand. I'm in two minds about anything that automates everything too much. It's great because it enables and democratizes the ability to do the work, but at the same time, by abstracting away some of the complexity and what have you within it, it means that if something starts to go a bit awry, you might not be in the best position to start troubleshooting, and that's when you need to bring in sort of external knowledge and experts to try and troubleshoot something. And then it comes down to making sure you consume that knowledge as an organization so that you can deal with it should the problem arise again. And you sort of it's that constant upskilling that you need to do. You can do it, and like I say, it can be very, very productive, but just be aware that it is a double-edged sword. For you don't see what's going on behind the curtain a lot of the time, and if something goes wrong, you're making a support call, and then you're back and to and fro with them, that type of thing. So yeah, that's right. And yep, please. Okay, so the question is there a silver bullet mechanism for pushing the governance back into the business off of the shoulders of the data engineer? That's summarized well enough? Pretty much, yeah. Yes and no, it depends. It's called data product, and Cy Whiteley has put out a couple of good videos recently up on the AA YouTube channel. Essentially, you look at data mesh, which is an interesting approach. I mean, I like the idea of a sort of SOA architecture, but you push the ownership of the data product back to a product owner who's a business owner, because they're the ones that know the value of the data, why they want the data, the format they need it in, who's going to be consuming it, where it's coming from. So by sort of moving to a data product culture, that's where you sort of push that back towards the business, and they should really be looking to take the ownership of it. And you're saying, okay, well, I will enable you by building the right underlying solution. I will be looking to build that API layer around it so that it can be consumed by other areas of the business, but I need you to own the data. Like I say, check out Cy's videos, because he goes into it a lot more depth, and he's got some very strong opinions which are worth listening to. But yeah, take the sort of the data product type approach. Really, you want it to be an entity. It's not a pipeline. It's not a database. It's essentially a business function wrapped up to be able to publish within the business, and that way things like the analyst teams can consume that more effectively and build sort of business-wide views of the data. If you've got the sales team know about the sales data, and the product team know about the product data, and then the board want a report on a dashboard, and the analysts have got the API to come in and say, okay, well, I'm going to pick that because it's well documented. I know I can trust that data, and then it goes from there. And then obviously that's where the scientists come in as well about predicting stuff. You've got that API, and it sort of really sort of turns it into something that is an entity within the business context rather than a technical context. Yeah. Yeah, so there's the documentation is always the first thing that's cut when it comes to saving time and money in projects. And it will save you time and money in a project, but it will bite you in the ass 6 months down the line when it adds additional time and complexity to subsequent projects because you don't know what you're looking at. So yeah, that's very much a painful element there. Okay, if I can summarize what you've said there for the people who are on the stream. So one of the attendees at the front row basically said they're doing an application modernization, and there's no documentation from something that's nearly 10 years old, and they're having to rewrite it in C# and Blazor, and it's causing you no end of trouble. Yeah. And you convey that to your management. Wow. So a month to do business. So, I mean, that shows the value of documentation. And as technical people, we understand that, but a lot of the business context and project managers will see it as just as a line on the project. So, cool. And with that, I think, if we wrap this one up now, if you want more questions, we'll be around for a bit. Either out near the door or out on the floor and stuff like that. So if you want to come and have a chat, feel free to do so. Thank you very much for your time. Really appreciate you attending.